This is a video from section 4.1 in a Calculus 1 class. The directions say to find the absolute maximum and absolute minimum of f on the given interval. And with that, we're going to take a look at problem 51. On 51, we have f of x is equal to 12 plus 4x minus x squared. And the interval is the closed interval 0 to 5. Now, one thing I want you to take notice of is that f is a continuous function on the closed interval 0 to 5. And so we are guaranteed to have a max, an absolute max, and absolute min. Now, here's how this problem works. I'm going to take the derivative, and that's going to be 4 minus 2x. And I'm going to find critical numbers, right? So I'm going to set f prime of x equal to 0. So 4 minus 2x is equal to 0. Subtract 4 on both sides, and we get negative 2x equals negative 4. Divide both sides by negative 2, and we get x equal 2. And one thing to note is that x equals 2 is in the closed interval 0 to 5. I only care about the critical numbers that are inside the interval. Now, let's go back to our function. Now, as a reminder, f of x is equal to 12 plus 4x minus x squared. And we want to test the endpoints. Namely, we want to test x equals 0 and x equals 5. And we want to test any critical number that is inside the interval. So in our case, we're going to test x equals 0, x equals 2, and x equals 5. And I'm going to plug those values back into the function. So when I do that, I get f of 0, which is equal to 12 plus 4 times 0 minus 0 squared, which is equal to 12. And then f of 2 is 12 plus 4 times 2 minus 2 squared. And when we do that calculation, we get 16. And then f of 5 is 12 plus 4 times 5 minus 5 squared. And when we do that calculation, we get, I believe, 7. So one thing to take notice is that x equal 5 produced the lowest y value and x equal 2 produced the highest y value. And so what we can say is f has an absolute maximum at f of 2, which is equal to 16. F has an absolute minimum at f of 5, which is equal to 7. And that's how we do problem number 51. Let's take a look at problem number 53. So on problem number 53, we have the following. We have f of x equals 2x cubed minus 3x squared minus 12x plus 1. And the interval is negative 2 to 3. And we're going to go through the same thing. And again, one thing to take note of is that f is continuous on the closed interval negative 2 to 3. So we're guaranteed to have an absolute maximum and absolute minimum. So we're going to take the derivative. And so we get 6x squared minus 6x minus 12. If I factor out the 6, I get 6 times the quantity, x squared minus x minus 2. So what I do is I'm going to set f prime of x equal to 0. And so 6 times x squared minus x minus 2 is equal to 0. Now I'm going to factor. So we get 6 times x minus 2 times x plus 1 equals 0. And so therefore, x is 2 or x is negative 1. And both of these critical values lie inside the interval negative 2 to 3. That's very, very important to keep note of the whole time. And so let's remind ourselves. So the function is 2x cubed minus 3x squared minus 12x plus 1. Okay. And let's check out what we're going to test. Now remember, we're going to test critical numbers. So in other words, we're going to test x equal negative 2, and we'll leave a little space, and we're going to test x equal 3. And then we're also going to test negative 1 and 2. So we're going to test x equal negative 1, and then x equal 2. And we're going to plug those back into the function to see which one gave the highest value, the highest y value, and the lowest y value. So f of negative 2 is going to be 2 times, if you don't mind, I'm going to write negative 8. That's what negative 2 cubed is. And then I'm going to write minus 3 times negative, well, I'll say positive 4, right? That's what negative 2 squared is. Minus 12 times negative 2 plus 1. Okay? And so that's negative 28 plus 24. That's negative 4. Negative 4 plus 1 is negative 3. And then f of negative 1 is 2 times negative 1 minus 3 times 1 minus 12 times negative 1 plus 1. And when we perform that calculation, you should end up with, it looks like you're going to end up with 8. And then I'm going to plug in 2. And when you plug in 2, you get 2 times 8 minus 3 times 4 minus 12 times 2 plus 1. And when we go through this, we get, let's see, 16 minus 12 is 4. 4 minus 24 is negative 20. Negative 20 plus 1 is negative 19. And then if we look at f of 3, we get 2 times 27 minus 3 times, looks like 9, minus 12 times 3 plus 1. And from here, we're going to get, looks like 54 minus 27 minus 36 plus 1, right? And then 54 minus 27, that's 27. 27 minus 36 is negative 9. Negative 9 plus 1 is negative 8. Now, I need to know the lowest y value. I need to know the highest y value. The lowest y value appears to be negative 19. The highest y value appears to be 8. And so let's make our conclusion. Now, f has an absolute maximum at, now remember, look for the highest y value. The highest y value is 8. So I'm going to say f of negative 1, which is equal to 8. Now, f has an absolute minimum at. And then if we go back, it's going to be f of 2 equals negative 19. Because negative 19 is the lowest y. And that's how we do problem number 53. Let's take a look at problem number 57. Suppose I give you f of x equals x plus 1 over x, and the interval is 0.2 to 4. Close. Okay. Now, again, f is continuous on that interval, so we're going to have an absolute max and min. That's going to happen. Now, take the derivative. This one's really good. F prime of x is equal to 1 minus 1 over x squared. Set f prime of x equal to 0, which says 1 minus 1 over x squared equals 0. Now, if you don't mind, I'm going to multiply through by x squared. Right? That clears the fraction. And so x squared minus 1 equals 0. Add 1 to both sides. And so we get x squared equals 1. But what does that tell me, though? That says x is 1 or x is negative 1. But x equals negative 1 does not belong to the closed interval 0.2 to 4. And so, therefore, the only critical number I care about is x equals 1. That does belong to the closed interval 0.2 to 4. Now, what are we going to test? We're going to test x equals 0.2, x equals 1, and x equals 4. Now, let's remind ourselves, f of x is x plus 1 over x, right? So I'm going to plug 1 in for x. And when I do that, I get 1 plus 1 over 1, which is equal to 2. If I plug 4 in for x, I get 4 plus 1 over 4. And I claim that's 4 and 1/4, which I'll write it as 4.25. That way you can get an idea of which one's the high, which one's the low. It's easier to see that when you have a decimal. Okay? And then if I plug in 0.2 for x, I get 0.2 plus 1 over 0.2. This one's really interesting. Now, check out what happens here. You get 0.2 plus 5, which is 5.2. And so it looks like the highest y value is 5.2. The lowest y value is 1, which I think is very interesting. And so, therefore, f has an absolute maximum at f of 0.2, which is equal to 5.2. And then I'm going to say f has an absolute minimum at f of 1, which is equal to 2. And that's how we do problem number 57. Let's take a look at problem number 61. And that'll be the last one for this video here. And so suppose I have f of t is equal to 2 cosine t plus sine 2t. And the interval is 0 to pi over 2. I like trig, so we need to be able to do some trig, right? Now, we're going to take the derivative. Remember that this function is continuous on the closed interval 0 to pi over 2. And so it will have an absolute maximum and minimum. And so this is negative 2 sine t plus 2 cosine 2t. Now, we need to recall something. Cosine 2t is equal to, we're going to start here. It's cosine squared t minus sine squared t. But I can write this as 1 minus sine squared t minus sine squared t. Okay? And then this is equal to 1 minus 2 sine squared t. And so, therefore, f prime of t is negative 2 sine t plus 2 times 1 minus 2 sine squared t. And I'm going to set f prime of t equal to 0. So negative 2 sine t plus 2 times 1 minus 2 sine squared t equals 0. And let's distribute the 2. So we get negative 2 sine of t plus 2 minus 4 sine squared t equals 0. Now, what I want to do is divide everything by negative 2. And when I do that, I get 2 sine squared t plus sine of t minus 1 equals 0. Now let's factor. So I get 2 sine t, leave a little space, and then sine t, leave a little space, equals 0. I'm going to put a plus 1 here and a minus 1 over here. So what that tells me is sine of t equals 1/2, or sine of t equals -1. Now, if sine of t equals 1/2, now remember, we're only dealing with the interval 0 to pi over 2. That's it, okay? So if sine of t equals 1/2, the only choice I have is pi over 6. If sine of t equals -1, the value of t will land outside the interval 0 to pi over 2. So we don't have to worry about that. We only have to worry about t equal pi over 6. Now, let's remind ourselves. F of t equals, and we get 2 cosine t plus sine 2t. And let's test. T equals 0, t equal pi over 6, and t equal pi over 2. If I plug in 0, I get 2 cosine of 0 plus sine of 0. But that's 2, right? Sine of 0 is 0. Cosine of 0 is 1. F of pi over 2 is 2 cosine of pi over 2 plus sine of 2 times pi over 2. And I claim that's 0. Okay. And then if I plug pi over 6 in for t, I get 2 cosine of pi over 6 plus sine of 2 pi over 6. Okay, sine of 2 pi over 6, that's sine of pi over 3, right? That's square root of 3 over 2. Cosine of pi over 6 is square root of 3 over 2. So we get 2 times square root of 3 over 2 plus square root of 3 over 2. So you get 3/2 times the square root of 3. Now, 3 square root of 3, right, divided by 2, think of square root of 3 as about 1.5. If I take 1.5 times 3, you get 4.5. 4.5 divided by 2 is more than 2, right? And so what that means is F has an absolute maximum at f of pi over 6, which is 3 root 3 over 2. F has an absolute minimum at f of pi over 2, which is equal to 0. 0 is the smallest y value. 3 square root of 3 over 2 is the biggest one. And that's going to conclude this video for, this is section 4.1, and we worked on problems 51, 53, 57, and 61. Okay, thank you.